Hello everyone, welcome to Technologies Discussion channel. Today, I'd like to continue the discussion on wireless connectivity. On the part 1 series discussion, I have discussed how can we actually classify wireless connectivity by the area or the zone. Firstly, I mentioned that we can classify as PAN, personal area network, then will be by LAN, local area network, and then by methodology area network and wide area network. So in fact, I have not gone through the last one, which is the global area network. But this video again, I'm going to discuss on the classification of connectivity. This video, I'm going to concentrate on the first two, which is the range and transmission power, data rate and bandwidth. So this video I will concentrate on these two. The next video, I will concentrate on security and latency. And on my third video, I will discuss on the power consumption and the number of connected device. So basically this will be the series discussion based on the classification of wireless connectivity. Why the range and transmission power? You can see that these two terms, they are actually closely related. If I'm going to have a big transmission power, then you can see that we actually will be able to achieve a longer range. If my transmission power is very limited, then I will have some constraint on the range. Next will be on data rate and bandwidth. Again, if I have huge amount of data, then I need a huge bandwidth to carry the data. However, for IoT application, then I need to have a narrow band, just narrow band, enough to carry the data. So basically this will be the objective of this video. This will be the part 2 series discussion on wireless connectivity. So guys, if you're keen to know more about wireless connectivity, please take a look on the playlist under the description. Over there, you will be able to find a series of discussion on wireless connectivity. This is my email. If you have any question regards on this discussion, please drop me an email. Or if not, if you want to have a faster response, you are always welcome to ask me through the comment. Before I continue, I'd like to urge you guys to help this channel by like this video. For those who are new to this channel, please consider to subscribe and turn on your notification bell. Once again, thank you so much for strong support. Let's quickly understand how can we actually classify connectivity based on the range and also the transmission power. When we actually classify the wireless connectivity based on the range, the transmit power actually play a significant role. And it actually determines the signal ability to travel further distance while maintaining reliability. So this is what I mentioned earlier on. The higher the transmission power, the longer the range. So therefore, this is actually proportional. So next, will be a detailed explanation of wireless technology that will be categorized by range, considering their transmission power and their typical application. So basically for range, we can classify as short range, medium range, long range, and ultra long range wireless connectivity. So let's take a look on this 4 category, where we actually classify connectivity with range. Firstly, when we actually mention about short range, the range is typically maybe a few centimeter or maximum up to 10 meter. So basically for short range, the so-called the maximum range is up to 10 meter. As for transmission power, so typically, because of the short range, we just need a very little amount of data, typically maybe up to 1 milliwatt, or maybe just to have a few milliwatt, that's all. So the key feature of short range will be limited range. However, it is actually suitable for close proximity or personal area network because they transmit a very low power. So therefore, they are actually energy efficient and they are actually often used for portable device, which allow them to be powered up by batteries. Some key example of short-range wireless connectivity will be NFC, near-field communication. So the typical range is about 4 to 10 centimeter. I think not even 10 centimeter for NFC, maybe around 5 centimeter. I think that is roughly the range of NFC. As for transmit power, they are very low. Typically just around 1 milliwatt. So where is the application? For example, we have this contactless payment. Nowadays we actually have a mobile phone they can allow us to have contactless payment, some form of tickering, and also smart card. Okay, so basically these are the application for NFC. Next will be Bluetooth Low Energy. Okay, before I start on this Bluetooth Low Energy, I like to highlight that there are actually two different types of Bluetooth. One is we call the convention Bluetooth. This Bluetooth Low Energy, BLE, which means that they actually use very low power. When they actually use very low power, the range maximum can be up to 10 meters. Okay, so nothing more than 10 meters. The transmit power actually vary, but typically you can see that they actually kept it under 10 milliwatt. Okay, because of this BLE, okay, which means that they actually prolong the battery life. Okay, so therefore this will have some application, like for example our wearable watch. Okay, we have the watch to keep track our fitness tracker. Okay, basically we can also see that some so-called soccer player, they actually wear a heart, so-called monitoring the heart. Okay, so basically all these can be used by Bluetooth Low Energy, and smartwatch is also another feature of Bluetooth Low Energy. Okay, and then last but not least, under this short range wireless connectivity will be Zippy. Okay, so Zippy has a longer range, okay, typically about 20 meter. Okay, so most of the time, okay, Zippy will be implemented indoor. Okay, however, it can also implement at the outdoor. But for this case, under short range, they most of the time will be under so-called indoor, and then mainly like for home, smart home, etc. Okay, so the transmission power, okay, is almost the same as BLE, okay, maximum up to 10 milliwatt. Okay, as I mentioned, Zippy probably you can do some home automation or smart home, smart lighting, etc. Okay, so let's move on to medium range. Okay, so let's move on to medium range. Okay, so medium range is typically, let's say, close to 10 to 100 meters. Okay, so basically the range actually slightly increased. And because of the increase of the range, okay, you can imagine that the transmission power need to be increased also. So for this case here, typically they are in the zone of 10 milliwatt, close to 100 milliwatt, nothing more than 100 milliwatt. As for the key feature, okay, so for this is basically they want to balance the range and also the energy consumption. So basically, as I mentioned earlier on, range and transmission power, they are highly correlated. When you actually increase the range, you need to increase the transmission power. So therefore, okay, we actually want to optimize it. So therefore, we just want to have this optimization in terms of the range and also the energy consumption. Okay, so this is actually ideal for local area network and maybe for some small home and office setup. Some example of medium range wireless connectivity. Okay, so under Wi-Fi, we actually have so-called the indoor and outdoor. Okay, so the Wi-Fi that we actually had in our home, okay, topically, they will be covered in this zone here, okay, which is called Wi-Fi indoor. The range, okay, so basically you can see that the range is slightly longer as compared to the short range. So basically from here, you can see that they can be up to 50 meter. The transmission power, okay, it can be up to 100 milliwatts here. Okay, so Wi-Fi, I guess you know the key application can be access to internet, how we actually share the file. We can also use this to build a smart home application here. Okay, so next, another example for medium range wireless connectivity will be classical Bluetooth. So basically, this is what I mentioned earlier on. On the short range will be Bluetooth Low Energy. So this is actually the classical Bluetooth. Okay, so basically this classical Bluetooth, can imagine that our mobile phone, okay, supporting the music on the headset. Okay, so basically this is what we call a classical Bluetooth. The range, okay, is slightly longer, which is about 100 meter. Okay, as for the transmission power, okay, you can see that it's basically in between 2.5 to 100 milliwatts. Okay, so as I mentioned about the application, okay, it can be, for example, to support our headset, okay, wireless keyboard, and also the mouse. Okay, so basically for Z-Wave, okay, another example of medium range wireless connectivity. Okay, the range is up to 100 meter. Okay, the transmission power is much more attractive at 10 milliwatt. The key application is again, okay, same as Zigbee for smart home automation. So basically, you can imagine that Z-Wave is actually a competitor of Zigbee. Okay, so next, let's move on to long-range wireless connectivity. Okay, for the range, okay, you can have 100 of meter, maybe 100 meter, 200 meter, etc., and maybe up to several kilometer, maybe 1K, 1.5K, etc. So as for transmission power, the range will be from 100 milliwatt up to 1, 2, 3 watts, etc. So for the key feature, they actually provide wide coverage. Okay, the longer the distance you need, okay, the larger the transmission power, and hence because of this, this is actually preferred, okay, for outdoor and wide area network. Okay, so this is often used for public network. Okay, basically you can imagine our mobile service fall under this so-called mobile network for IoT application and maybe some infrastructure system here. Let's take a look on some example of long-range wireless connectivity. Okay, earlier on I mentioned about Wi-Fi indoor. Okay, so we also have this Wi-Fi outdoor. Basically, they transmit a larger power, and because of the larger power, you actually can have a longer range. So basically, this is Wi-Fi indoor and outdoor different. Basically, with higher power means that longer range. So basically, for the key application will be campus network, okay, point-to-point wireless link. Okay, as for another example will be LoRa. Okay, so LoRa is one of the LPWAN, low power wide area network. So as for the range, okay, is up to 15 kilometer. Okay, maybe I should say around 10 kilometer. Okay, so basically I mentioned that it will be several condition. Okay, so basically you need to fulfill several condition in order to achieve 15 kilometer. But in short, I think 10 kilometer is quite a reasonable number. Okay, transmission power is actually very attractive. Okay, so basically LoRa is LPWAN. LPWAN means low power. So from here you can see that the transmission power is around 100 milliwatt. Key application for IoT, environment monitoring, etc. Okay, so last but not least, another example of long-range wireless connectivity will be something that we are actually very familiar. Cellular network, okay, 3G, 4G, 5G, etc. Okay, so the range, okay, they can cover up to 10 kilometer, depend on whether is it urban or rural. As for the transmission power, okay, you can imagine that for the base station, they are actually quite high. It can be up to 30 watt, for example. As for our mobile phone, our mobile device typically is around 200 milliwatts. So I guess you know what will be the key application. So will be a mobile broadband, okay, voice or data communication. So basically this is for the long range wireless connectivity. Let's move on to ultra long range wireless connectivity. Okay, the range will be 10 or even 100 of kilometers. So basically this is very far away in effective communication here. The transmission power, you can imagine that you are going to have a huge amount of transmission power in order to support the long range. So the key feature will be they actually utilize high power transmitter so as to achieve extensive coverage. Okay, so most of the time, this is actually operate in a licensed spectrum. Okay, because you do not want to have any interference because you are going to transmit the signal long away, long range. So therefore, most of the time, you will prefer to so-called comms under the licensed spectrum in order to have the reliability and also to reduce the interference, like I mentioned earlier on. So under ultra long range, we have satellite communication. Okay, I guess you know that for satellite communication, it could be even thousands of kilometers away. So for the transmitter, for the satellite, okay, so you can see that the transmitter for the satellite, okay, is slightly lower as compared to the ground station, okay, because the ground station, okay, we can have more power because we actually can control the amount of power when we actually on the ground. But for satellite, typically they will transmit a lower power because they may have some issue in terms of generate the power. For ground station, we don't have much issue, so therefore we can transmit up to even kilowatt. Okay, as compared to satellite, probably around 200 watts. Okay, so the key application, okay, I think you know GPS, satellite comms, global communication, etc. So there's another example of ultra long range wireless connectivity, okay, under this microwave link. So the range is up to 50 kilometer. Okay, so slightly closer, maybe on the earth where we actually communicate from country to country. Okay, so basically you can see that the effective range is up to 50 kilometer. The transmission power, we don't need so much as compared to the satellite communication. Okay, so basically it is up to 100 watts. Okay, so the key thing is will be the backhaul for cellular network and also for broadcasting purpose here. So let's move on. Okay, so basically I have this table to summarize, okay, the wireless connectivity in terms of the range, okay, with respect to the transmission power. So under short range, okay, less than 10 meter. Okay, so you also need to have a very little power. You don't need big power to go for short range. Okay, so basically you can see from here, key application which I have explained, and also the key application I have also mentioned just now. As for medium, you can see that the range actually increased slightly as compared to short range. Same for long range, you can see that the distance actually increased up to 10 kilometer. As for ultra long range, okay, the distance can be more than 10 kilometer. Earlier on, I mentioned about satellite communication. So that is even in terms of 300, 3,000 over kilometer, etc. Okay, so you can see that the transmission power, okay, they can also vary, but you can see that when the range actually increase, the transmission power also increase. Okay, so key example on the wireless connectivity. Okay, so you can see that these are classified under so-called low power device here. You don't need a lot of power because they only serve a very short range. So next you can see that the power increase. So basically for Wi-Fi indoor, this Bluetooth, convention Bluetooth, and also the Z-Wave here. So next will be a Wi-Fi outdoor. They transmit a larger power, so therefore they can go for a longer range. This is one of the LPWAN and also the cellular network 3G, 4G, 5G, etc. And then last but not least, in terms of the ultra long range will be satellites and microwave link. Okay, so with this, let's move on to the next one, okay, which is the bandwidth. Okay, so before I continue, so guys, if you have learned something from this video, okay, please help to like this video. Again, I like to encourage you to subscribe, okay, if you find this information useful. Okay, so let's continue on the another discussion here on the data rate and also the bandwidth. Okay, earlier on I mentioned that if we want to have huge amount of data, then we need to have huge amount of bandwidth to carry the data. If the data rate is very limited for IoT application, then I can afford to have a narrow band to carry the data. Okay, so wireless connectivity can also be classified based on data rate, okay, and also bandwidth. Okay, so basically this is what I mentioned earlier on. Okay, the speed at which data is transmitted, bandwidth is the frequency that the signal actually occupied. Okay, so these factors are critical for determining the suitability of a wireless technology. Okay, for specific application such as low power IoT sensor or high definition video streaming. Okay, so basically from here you can see that based on your application. Okay, so with your application, for example, for video, then you need to have high data rate. And because of this, then you need to have high bandwidth to carry the high data rate. So therefore, you are actually constrained. So basically, this is one of the classification, okay, of wireless connectivity. For example, for the use case of IoT, you just need some very little amount of data, so you can actually afford to have narrow band to carry the data. Again, under the data rate, okay, we can have low data rate, and therefore we need to have just a very narrow bandwidth to carry the data. We also can afford to have medium data rate, and therefore we have a moderate bandwidth here. Next, okay, we have high data rate, okay, which means that, for example, some video streaming here. Therefore, we need to have a wide bandwidth to carry the data. Last but not least, under this ultra high data rate, then we need to have UWB to carry the signal. So from here, you can see that the different classification of data rate for different application. Based on your application, therefore from here, you decide the amount of data that you need, and thereafter you actually constrain to one of the type of the wireless connectivity that you can actually choose on. Okay, so let's move on. So low data rate and narrow band. Okay, so basically the low data rate is typically maybe up to 100 kilobits per second. Okay, in fact, Sigfox has even lesser data as compared to this. Okay, so because you don't need a lot of data rate, so the bandwidth you can constrain, so you can have a very narrow band just to carry the data. So typically, maybe up to a few kilohertz or up to a few hundred kilohertz. So it's very narrow band of bandwidth here. So the key feature is going to optimize for low power, low data transfer application here. So this is excellent, okay, for long range communication, okay, due to the narrow bandwidth. Okay, you can imagine that the narrow the bandwidth, the less noise we have, and therefore we can afford to travel a longer range. Okay, so basically, if you're keen to know about this, please see some of the video in this channel. So this form here is actually ideal for device with limited power. Okay, LPWAN, for example, we always like to constrain in terms of the power so that we can go for long range. And basically, we don't need to send the data very frequent. So basically, this is what it means under this key feature of data rate and bandwidth. Some of the example for low data rate and narrow bandwidth here. So earlier on, I have mentioned about LoRa. Okay, so again, LoRa actually support low amount of data rate, and you just need a very little bandwidth to carry the data. From here, you can see that data rate for LoRa can be from up to 50 kilobits per second. Okay, LoRa actually use this spread factor. Based on your spread factor, okay, basically will be the amount of data you will be able to send. Okay, so again, LoRa is a spread factor, so the bandwidth is not fixed. So they are from 125 to 500 kilohertz here. So some of the key application, in fact, not only this, I think there are wide amount of application for LoRa. So some for environment monitoring, smart agriculture, etc. Okay, next one will be the pioneer for LPWAN, which is Sigfox. Okay, so Sigfox has the lowest data rate as compared to the rest of the LPWAN, about 100 bits per second. Okay, again, because Sigfox is using so-called frequency hopping, so therefore the bandwidth can be very narrow. In fact, one of the most narrow bandwidth, it just need 100 hertz to carry the data. Key application, okay, so Sigfox has a long battery life, okay, because they only utilize very little power. Okay, so therefore this is considered as a low power IoT, and they are mainly used for asset tracking. Okay, last but not least, under this low data rate will be Zigbee. Okay, so in fact, if you take a look on Zigbee, Zigbee in fact has the largest data rate as compared to the other LPWAN here. Okay, as for bandwidth, again, because they need more data, so therefore they need to have a larger bandwidth to carry the data. So again, I have mentioned this, the application for Zigbee mainly is used for home automation and maybe in some form of industry IoT. Okay, so let's move on to medium data rate and also moderate bandwidth here. So therefore, from here you can see that the data rate actually start to increase slightly here, up to 100 megabits per second, and you just need maybe a few megahertz to carry the data. So some of the key feature is they actually want to balance the power efficiency versus the range and also the throughput, okay, which is the data rate, which means that when we actually use this medium data rate, okay, we actually want to save the battery as much as possible. However, the amount of data that we send, okay, is considered more than the low data rate. So therefore, we need to do some form of balancing so that we can have enough power to last for a longer time, and we can satisfy a bigger range with so-called slightly more than low data rate throughput here. So basically, this is why we need to have medium data rate and moderate bandwidth. Okay, so this form here is actually suitable for applications that require moderate data transmission, such as audio streaming or basic file sharing. Okay, so basically, this fall under medium data rate and moderate bandwidth. So some of the key example for medium data rate, okay, which is the classical Bluetooth. Okay, for the classical Bluetooth, the data rate can be up to 3 megabits per second. And if you still remember from my Bluetooth discussion, it's actually using frequency hopping. Okay, so all the frequency hopping, every channel, they only have 1 megahertz of bandwidth here. So key application, okay, as I mentioned that this is a classical or conventional Bluetooth, so they can support, okay, headset, okay, play the music via the mobile phone to the headset, okay, and also some of the wireless mouse, keyboard, etc. Okay, so we have another low end of Wi-Fi. Okay, so these are so-called the early days Wi-Fi. So they fall under this medium data range, and they don't need a lot of bandwidth here. So this is what we call the very old days of Wi-Fi standard 802.11, A standard, B standard, and G standard. You can see that these are very old days of Wi-Fi standard here. So they only just be able to carry just very little amount of data, so therefore the bandwidth don't need to be large. But at the time, okay, for this Wi-Fi at the low end, they can support, okay, even our home or maybe even office network here. Okay, so basically this can be a very useful to access internet in the very early days of the Wi-Fi era. Okay, next will be on Z-Wave. Okay, the Z-Wave data rate can be around 100 kilobits per second. Okay, you can see that the bandwidth to carry the data is around 9.6 kilohertz here. Okay, they have just very little bandwidth to carry reasonable amount of data rate here. So as I mentioned, Z-Wave is actually a competitor of Zigbee. So again, you can see that the application is quite similar with the so-called the Bluetooth low energy. Okay, so basically this is fall under medium data rate and moderate bandwidth. Okay, let's move on to high data rate and wide bandwidth here. So the data rate for high data rate is basically up to 1 gigabits per second. Okay, as for bandwidth, because of the large amount of data, you probably need in terms of hundreds of megahertz in order to carry the data. As for key feature, they are actually designed for high-speed data transmission, okay, over short to medium distance here. So therefore, they actually require a higher power and bandwidth resolution here. So this is ideal for multimedia or maybe even for some gaming. Okay, so gaming nowadays actually went to ultra high data rate. Okay, but over here, okay, I think there's some of the gaming, in fact, you just need to high data rate will be able to achieve so-called seamless connection to the internet. Okay, so basically this is high-speed internet here. So some of the example, okay, so these are where we are. on the Wi-Fi high end. Okay, so basically we are actually at Wi-Fi 6E. Okay, so basically the amount of data, okay, can be up to 9.6 gigabits per second. Okay, you can see that the bandwidth actually increased slightly in order to carry more data. So key application, okay, we have video streaming, online gaming, high-speed internet, etc. Okay, next will be another example will be 4G. Okay, so 4G actually has a data rate of 100 megabits per second all the way up to 1 gigabits per second. Okay, so basically this is what I want to emphasize is on the theory. Okay, so basically this is not possible in the practical world, but for theory, okay, 4G LTE can be as much as 1 gigabits per second. As for bandwidth, okay, you know that 4G actually has different channel, so therefore the bandwidth also vary, either 10 or 20 megahertz here. So basically, the key application, okay, I know you probably very familiar what you can do on your mobile phone. You can surf the internet, you can do live streaming, etc. Okay, let's move on to the last one, okay, which is the ultra high data rate, okay, which you need to have ultra wide bandwidth to carry the data. So the amount of data that we consider ultra high will be greater than 1 gigabits per second. Okay, so basically will be millimeter wave 5G. Okay, so the bandwidth is hundreds or even up to gigahertz here. Okay, so even now with Wi-Fi 7 or Wi-Fi 6E, okay, they actually expand the bandwidth even to the gigahertz. Okay, so basically these are some of the requirements which is mentioned here. Okay, so the key feature, okay, they actually support extreme high-speed data transfer. They require quite a substantial amount of power, okay, because we are going to have high data rate and therefore we need to have certain amount of power and some advanced technology like beamforming, okay, which is part of the 5G millimeter wave. So these are all essential, okay, for application like, for example, AR, VR, that you need a lot of data rate. So therefore, okay, they actually fall under this ultra high data rate here. Come to the simple example for this ultra high data rate and UWB is basically 5G millimeter wave. Okay, I'm not sure whether you know that for 5G there are actually two band. One is we call sub-6, okay, which is the lower band. Okay, at the higher band we call this 5G millimeter wave. Okay, so this having a higher frequency, they can support a data rate up to 20 gigabits per second. And you can even have up to several gigahertz to support this kind of application. The key application, again, is all those AR, VR, or even nowadays 5G also support IoT, mainly is with massive connectivity, which means that this form of 5G millimeter wave, they can support many, many devices connected to it. Okay, so these are the much more advanced Wi-Fi standard, etc. So basically, these are very new. Okay, the data rate can be up to 10 gigabits per second. The bandwidth is up to 2 gigahertz here. So basically, you can see that the key application for wireless docking station or even ultra fast file transfer. Basically, you can transfer your file from one end to another end in a split second. Okay, so last but not least, okay, so basically I have this comparison table to compare the data rate and bandwidth here. So you can see here the amount of data actually increased. Okay, so basically from 100 kilobits per second all the way up to 1 gigabits per second. Okay, so under this ultra high data rate, you can actually send huge amount of data. And with huge amount of data, okay, so basically this is desired. From here, I have also quickly mentioned that the bandwidth also vary. When you actually have large amount of data, then you need to have a huge bandwidth to carry the data. So from here, you can see that the bandwidth also increase proportional with the data rate. Last but not least, on term of this example, okay, I have explained the different so-called wireless technology that using low data rate, okay, LPWAN or even NB-IoT should be also under this category. Okay, we also have this medium data rate, okay, which is the Bluetooth, okay, and then we have the low-end Wi-Fi and also the Zigbee. Okay, we have this high data rate much more advanced of Wi-Fi. Here we are currently using this form of Wi-Fi standard 4G, etc. So this is something that we are using on the 5G. These are the newer so-called Wi-Fi standard here. So key application which I have explained. Okay, so I will not touch on this furthermore. So with this, I like to end my discussion. Okay, please help to like and subscribe. Once again, thank you so much for strong support. I hope to see you guys soon. Bye for now. Thank you.